Hi, this is Claus. In this video we will piece together the custom sphere that we made in Blender and the texture that we got from the European Southern Observatory. They mentioned that it's important for them that I mention their name every time I have the texture somewhere. Yeah, we'll put all of this together to create our custom star sphere, and we will also make that we have a blue sky when the sun is up, because when the sun is up you don't see the stars because the sun is too bright. But before we do that, I will correct some minor mistakes or things that I didn't know. I mentioned that I didn't know how to include pi in the math expression, and some user, whose name I do not remember, commented that the fix is really easy and you just have to type pi and then open bracket, close brackets, like you do with cosine. You have to put something in brackets behind it. Pi doesn't need an input, but still you need to put the brackets, and then the program will recognize that you don't want to create a variable called pi, but instead you want to call the value pi that is in the math function. Okay, for that we just click on the math expression, press F2 for rename, then we click on pi, zoom in, and I'm gonna open bracket, close bracket, press enter, and there you go. So no more variable pi. I can close the node getPi, don't need that, and now pi is within the math function, and I think that's better. Yeah, and then I had a great idea that I could also fix the whole and remainder thing, because all I want to do is what we call modulo. So you can do that in here as well. Just click on the math expression, press F2, and then put brackets at the start, open bracket, and closing bracket at the end. And then at the end you just type in the percentage sign, that is for the remainder, and then you type in 360 in this case, that was our divisor, and press enter, and now you can directly plug it in here. You don't need this node. Boom! Isn't that great? I think both of these are things that I could have known by myself, but I don't know, sometimes it just doesn't click in my head. And this one we don't need either. Just click on this math expression, press F2, first sign, open brackets, last sign, closing brackets, percentage sign for modulo. That will give us the remainder, and the divisor shall be sun year duration. See? Exactly the same. Remainder, sun year duration, remainder we will use, and the divisor sun year duration. So we don't need these, and we can plug this in directly. So as far as I've heard, math expressions are far more well, they use up less performance than the blueprint nodes, so this should be better. Yeah. Okay, so we have fixed this little mistake. So thanks again to that YouTuber that gave me that hint. That was really good. Thank you. And now we can import the assets we created in the last video. So that for one is the sphere with the inverted normals. Just click on import all. No smoothing group, etc. I don't know what that means, so just ignore it. If you know what that means, please comment. I don't know if that's important. And the other thing you need to import is, of course, the picture of the Milky Way that the European Southern Observatory created over the course of, I think, 1 year. And that picture shows all the stars in the sky that you can see with the naked eye under perfect conditions, no light pollution and stuff like that. So first of all, let's include that sphere into our blueprint. So we already have the sun rotator and the sun. So click on default scene root, add another arrow. Those are kind of helpful because you always know where they're pointing because they're arrows. That's why they use them. And I call that, what was it? Star sphere rotator. Rotator. And then I add another component, another arrow. And I call it precession rotator. And I will not tell you what that is about if you don't know already. We will deal with that at a later time. And now we can add in our star sphere. Just drop it on the precession rotator so that it has the right position in the tree. You can already see it in the level. It's kind of small. Can check it out. Boing. So scale 1 is too small. We made it 10 meters, so that's 10 meters in Unreal Engine. Not very impressive. So let's set it to, I don't know, 50. That should be big enough for whatever you need to do. Let's give it a short check. Yes, so you can see it takes quite a while to reach the edge. So you will have to figure out how big you need the sphere to be so that you don't bump into the sky. That would be embarrassing, right? But 50 is good enough for now. Now this doesn't look like a star sky. We need to create a material with a stars texture, put it onto the sphere. So right click, material. I'm gonna call it m underscore star sphere. Open it. Nothing to see. I drag the texture of the sky from the European Southern Observatory and I drop it into the material, which automatically creates a texture sample node. Now, yeah, I'm gonna use a scalar parameter. Yeah, or at first, yeah, I will just plug it in. And it's important you plug it into emissive color, not base color, because there will not be light shining onto that sphere, but the sphere itself has to emit the color, which is reasonable because they are stars. They emit light. But you can't have a light shine on them because it would create a shadow and a hot spot where the light shines. That wouldn't be good. Now let's first apply this, and then we have to go to the star sphere, details, materials, click, type in star, and choose your star sphere, and there you go. And now we compare it with the texture from the European Southern Observatory. I'm going to take this spot because you can it's quite distinct from the rest. Let's pull that over here. Zoom in a little bit, because I want to show you something that happens when you invert the normals of a sphere. We go to the same spot here, and you can see this is the same spot, right? You recognize it? Color is a little bit different, it's a bit bright here. But that is the raven head, that's the beak, and that is Santa Claus. Of course, I just made those names and figures up. And here's the raven head, and there's its beak, and there's Santa Claus, so the image is mirrored. So we have to fix that. Simple fix. Just go to your material, right click, type in TE. That brings you a texture coordinate. And there you drag a wire, and you type in BR for break. And you get breakout float 2 components, which just gives you the individual values of the texture coordinate U and V. And now the R value we have to invert. So to drag a wire, type in 1, and there it is, 1 minus. And then we drag another wire, type in APP, and we get the append vector. And now we plug in the G into the B, the R goes into the 1 minus and then into the A, and both combined go into the UV. And let's have a look. Santa Claus on the left, apply, Santa Claus on the right. Fixed it. Great. Next thing, we add in a scalar parameter. Right click, SCALA, there you go, scalar parameter. And I will call that stars brightness. And we drag from the RGB, type in M, it gives you the multiply node, and I plug in the scalar parameter, and both combined into the emissive color. Default value should be, say, set it up to 1, doesn't matter. And the great thing about a scalar parameter is it's not a fixed value you can only change within the material, but you can create a material instance and change that parameter during runtime, or rather by a blueprint, that is to say. You can change it by runtime too. Yeah, save now. So you can just enter the value in the blueprint, and that's really nice. So next thing, the sun might be up. If the sun is shining, you will not see the stars. Instead, the sky will be blue. So we need a blue sky, and add that in with the texture of the stars. So I will right click, and that is a vector parameter, a vector parameter that I call zenith color, because that's what it's called in the original BP sky sphere. And I double click because it's black. That's not what the sky is supposed to look like. Bump up the brightness, make this blackish, I don't know, something like that. Pick a blue that, I don't make it blackish, I make it bluish. Pick a blue that you like. Yeah, that I have to multiply again. Drag a wire, type in M, gets you the multiply node. With another right-click scalar parameter that I call Skyblend. Skyblend, because why not? Default value I leave at 0. For convenience, I don't know. And now drag a wire here, type in add, gives you the add node, and I plug in the multiply node from the blue sky color and the multiply node of the stars texture, and then the add node I plug into the emissive. So now I can just say with the blueprint, do I want the blue sky to be blend over the stars. I think this should work. Fairly optimistic. So that is good enough for the material for now. But I have to do another thing with the sky sphere, with the star sphere, as we call it here. Because right now the star sphere is getting light from the directional light. I don't want that. So when you go click on the star sphere, you have the details on the right, and then you have the lighting. And within the lighting you have the light channels. And that determines which of those 3 available light channels will illuminate, cast a shadow onto our star sphere. And that should be none of them. This actor will not receive any light whatsoever. Nothing. Okay. That's it for now, and wait a moment. Yeah, that's it for now, and in the next video we will hook up the sunlight, sun vector and all that stuff, so that we get a new disk within the material that represents the sun, like it is in the BB sky sphere, and a blue sky when the sun is up. On to the next video.